Howdy. Scientists discover a massive groundwater system in sediments below Antarctic ice. That's from today. Previously unmapped reservoirs could speed glaciers and release carbon. Many researchers believe that liquid water is a key to understanding the behavior of the frozen form found in glaciers. Meltwater is known to lubricate their gravelly bases and speed up their march towards the sea. In recent years, scientists in Antarctica have discovered hundreds of interconnected liquid lakes and rivers cradled within the ice itself. And they have imaged thick basins of sediments under the ice, potentially containing the biggest water reservoirs of all. But so far, no one has confirmed the presence of large amounts of liquid water in below ice sediments, nor investigated how it might interact with the ice. Now, a research team has, for the first time, mapped a huge, actively circulating groundwater system in deep sediments in West Antarctica. They say such systems, probably common in Antarctica, may have as yet unknown implications for how the frozen continent reacts to, or possibly even contributes to, climate change. The research was published in the Journal of Science 5th May 2022, which was yesterday. All right. We have glaciers, many. The Williams Ice Stream. Electromagnetic imaging stations were set up in two general areas, yellow markings. The team traveled to wider areas to perform other tasks shown by red dots. Click to the images. Okay, 62 miles, 29 miles. People have hypothesized that there could be a deep groundwater in these sediments, but up to now, no one has done any detailed imaging. Said the study's lead author Chloe Gustafsson, who did the research as a graduate student at Columbia University Lamonterti Earth Observatory. The amount of groundwater we found was so significant, it likely influences ice stream processes. Now we have to find out more and figure out how to incorporate that into models. Scientists have for decades, flown radars and other instruments over the Antarctic ice sheet to image subsurface features. Among many other things, these missions have revealed sedimentary basins sandwiched between ice and bedrock. But airborne geophysics can generally reveal only the rough outlines of such features, not water content or other characteristics. In one exception, a 2019 study of Antarctica's McMurdo dry valleys used helicopter-borne instruments to document a few hundred meters of subglacial groundwater below about 350 meters of ice. But most of Antarctica's known sedimentary basins are much deeper, and most of its ice is much thicker, beyond the reach of airborne instruments. In a few places, researchers have drilled through the ice into sediments, but have penetrated only the first few meters. Thus, models of ice sheet behavior include only hydrologic systems within or just below the ice. So I don't want to bore you with the whole article. I haven't read the whole article yet. To distinguish bedrock sediment and ice. Salty water conducts energy better than fresh water, so they were also able to show that the groundwater becomes more saline with depth. Key said this makes sense because the sediments are believed to have been formed in a marine environment long ago. Ocean waters probably last reached what is now the area covered with the Williams during a warm period some 5,000 to 7,000 years ago. 6,000 years, in other words, a half cycle. Saturating the sediments with salt water. When the ice re-advanced, fresh meltwater produced by pressure from above. and friction at the ice base was evidently forced into the upper sediments. It probably continues to filter down and mix in today. Okay. I made some 4 months ago a video where I talk about mountain water, about the water's role in the creation of mountains. Like here, down here is the water which will rise up. And it will make the connection to the waters from above. And usually the connection ends where we have a top of a mountain. That's why we have those wells all over the place in the mountains. And you could imagine these lightning strikes. They are drilling holes through the mantle and crust, and they penetrate as deep as they penetrate. That's why in certain areas we have volcanoes which erupt with magma, or like, how to put it, basaltic, like metal-rich rock, like you see in La Palma or Hawaii or Iceland, this kind of stuff comes from deeper, I guess. But on top of that, we have layers of water, we have layers of other sediments, we have many things in between. And also the erupting red lava, what everybody knows when someone is talking about lava. That's just part of the whole system. There is not just red stone pouring out of volcanoes. There's also water pouring out. There's like this kind of white stuff, rhyolithic lava based on silica, or silica-rich lava, which is basically lava based on water. Since everybody knows hot metal and water are not friends. That's why I think there is a counterpart to this kind of lava, which is based on water. And also the researchers here in the Antarctic have noticed that there is much more water than they thought there is. But I wanted to show you still Nullschool. That's the Nullschool application. I will put a link below. And I just wanted to show you, I haven't watched it yet. Air, wind, and then we want to go to 10 hectopascals, which is the highest attitude we can get of the winds on Earth. That's the North Pole. There is nothing going on. And that's the highest. If you go down like to 500, there is quite much more going on. And if we go to the surface, again, it's quite silent. But now we go to the highest, 10 hectopascals, 30 kilometers, I'm not sure, maybe. Check out the South Pole. And we aren't in summer yet. We are a few weeks into spring. And this looks already like this. So, North Pole, South Pole. North Pole, South Pole. And Earth. So now I just wanted to show you that there are some similarities between planets in our solar system. And I'm not saying it's the same. And I'm not saying that, how to put it, that is nothing to worry about. It's just, I just wanted to point it out. Because the difference between Earth's North and South Pole is quite big if you compare the activity of those two. Even though that, like I said, we are just into spring, we are not even into summer yet. And it's already like that, somewhat polarized Nothing going on in the north and nothing going on in the south. And a few weeks back, Neptune has fallen. Suspicious observers. I just wanted to show you, to refresh or to inform you.
Now, folks, here's why I'm not sleeping in today. Neptune's atmosphere has shuddered in a shockingly short amount of time. The drop in temperatures across the sphere of Neptune defy the onset of its summer, and just as curious is why is there a super hot spot directly at the South Pole while the rest of the world is getting colder? They are
So now you can watch the whole video. It's just somehow I thought it's really interesting. Like if that's Neptune and that's Earth. Maybe it has to be like this. But somehow it seems, I don't know. I would have expected to be there, like still some polar circulation vortex going on, despite me telling the news about the polar vortex collapse. But I somehow wouldn't have expected that there would be so little activity. It's really interesting. Our magnetic North Pole is somewhere here at the moment, traveling downwards, southwards, towards this region, probably, which will be the new North Pole. It's the same region where this buoy got shut off. We could actually check it out and then I will leave it. National Data Buoy Center. And we want to see this region. That's the region where it seems our magnetic pole is migrating towards. And that's the buoy which had activity, but now it's shut off, so there is no data or whatsoever coming in from that anymore. Nothing to see here. Just go on. But anyway, if you're one sport, you can count all those red buoys and also watch the regions in where the red buoys are. Is there probably some pattern about why in certain regions there is no data available? Or is it just like everything else, a random coincidence? I leave it up to you. But anyway, thanks. Bye.